Back working on Atlas index centers today, and what I'm working on is the index pin, which is M1-207, and it is this little pin right here. And this is the example that I've got that was in the other headstock that I'd purchased quite a while back that I patterned most of this stuff off of. So, and I've already started machining this. I've already turned the main body. I haven't done the end yet, but that's what I've done. They're just a simple turning. You know, there's nothing spectacular there. You guys can handle that. Everybody knows what's going on there. So what I found interesting more than anything else was the print for this part. And like I say, we've got an example to look at. And I believe this is a factory part. I could be wrong, but just from looking at dimensions, the way it's done and everything, I believe it is a factory part. Although the shank on it looks to me to be turned rather than ground. And that's part of the thing that goes with all of this that makes it intriguing to me anyway. And of course, the way this all fits together is we've got the spring. I've got the spring here, and I've come up with a spring that I think is a suitable replacement. There again, inexpensive, came from my local Ace Hardware, a little bit different and took a little modification, but I think it's fine. So anyway, pin sits right there just like that. That's the way it goes. So that's what we've done. Now, the thing that makes this interesting, and as we can see here, we've got a little bit of wiggle in that. You know, I'm not even going to try and measure it. It doesn't matter. So, and of course I'm fitting mine to this right here, which is my part. This is my spring that I'm going to use compared to what I believe to be a factory spring. Mine's a little bit lighter, a few more coils. They're about the same weight. Now this started out being twice as long, and it is a Hillman spring. And it's a number 5 Hillman spring. They look just like that. So, you know, I think they're 79 cents or something, you know, they're cheap. So there's no sense in buying expensive used springs from somebody on Fleabay. But anyway, enough of that. The thing that I found interesting is all of it. There's been some revisions to this. Now, the original date for this is what, 3/4 of 1940, I believe. 3/5 of 1940. So that's when this was originally drawn. Now there's several clues here and several things that make me believe that this is the original drawing, but these are not the original machining instructions. And they made some revisions along the way. Now, one of the things is, and I've said all along that most of the things on these Atlas machines are not as precise as everyone would like to believe. This is not rocket science. So when we go back here, they had a grind dimension. We've got a turn dimension here, but they had a grind dimension, and it's 1875, 187 to 1875. All of the dimensions on the factory part that I have here are smaller than that, slightly. I think out of this 187 here, I think I've got about 185 I measured, and on the nose of it out here, this 312 to 3125, I think I'm about 310. So, but one of the things is diameters must be concentric with 1/2 thou total reading. When you come back down here, there was a revision 521 of 43. They changed that dimension, or that tolerance, to 2/1000ths. So they realized right then that it didn't need to be that tight. And what I speculate is they probably loosened up the dimensions on the castings themselves. When they machined those, I think they probably found that they were already loose enough that if they, you know, to try and hold that close a tolerance, it didn't make any difference. So that's the first thing I see. Now, the second thing that I see, well, there's next thing, note 10.5 of 44. Note A, drawing, note and drawing added was B right here. We go to 10.13.47, note and drawing were removed. Now, I have no idea what that drawing was or what that note was. I would speculate that it, well, I don't know. I don't know what that note was. That would be kind of interesting to know. But in 912 of 48, turn diameter was added. So they added this turn diameter. So originally this would have been strictly a ground part apparently, or a finished ground part, but they've done enough with tolerances apparently that maybe they added the turn dimension first and then went back and were still continuing to grind. I don't know what the deal was there, but they added that at the end, and then the drawing was released on September 14th this was the final revision apparently in 49. So I found that interesting. But the thing that I really did find interesting was I think the drawing is different from these directions. When we look at this drawing, they've got a cross slot here, or a angled. This is not just a turn part like this is. I would believe that this is a later part than this drawing. And the reason I think that is this would have been easier to machine for one thing, and I think this potentially has the potential to be a little more accurate and easier to set up, because this is going to want to walk side to side. If you've got a cross slot, you're going to have to make sure that's straight when you set it down into the gears, and it would potentially get cocked sideways and not drop into the tooth of a gear when it was being used. So I think this was probably added later. Plus, when you tighten it down, if your tolerances were looser, why it would lock it into the same place rather than maybe canting it sideways. Now, when I build mine, I'm going to build mine like the drawing shows. The other reason that I think that it was probably machined this way, and I think that's what these directions are, is turn, chamfer, and cut off, machine number 85, speed is fast in forward gear. And I don't know what second means. I don't know if that's second operation. I don't know if that's second tool. I don't know exactly what that is. But turn, chamfer, and cut off would have been turning the shank, turning this outer diameter, cutting this chamfer, and parting it off, is what I'm assuming they're doing. Second operation would have been reversed. It's form, taper, and burnish maybe. Machine number 85, same machine, speed is fast, forward, and another second. So there, I don't know what the second is. But I would assume in both of these instances, well, it's the same machine, I would assume that that is a turret lathe of some sort. So if you're trying to cut this, I don't see how that could easily be cut on a turret lathe and have that tapered down on both sides rather than just turned all the way around. Or if it's turned all the way around in a turret lathe, well, you could form that. You could form whatever dimension you needed, taper it and burnish it. So I think that's probably what happened, and I think those two are different, and that's what leads me to believe that. So anyway, I'm going to start off and cut mine like the drawing shows. I'm going to put the bevel on it. If it doesn't work out right, I'll either modify it and just turn the taper on it, or else we'll build another one. It doesn't. This would, if you were doing something else where you had a set of index holes on the outside of a ring or something on your headstock there, that would index up better and drop right in, but I don't know that would, is a really practical application. Anyway, that's I found that interesting, so hopefully I haven't rambled on too long about that, but that's what I think I know. So there we go. Anyway, for this angle, what I did is I marked it, they call it a 29-degree angle. From here on out, it measures out to be, this is 3/4 of an inch long. It measures out on this one, and if you scale it on the drawing, which is full scale, why, you've got a half from here to here that's tapered, and then you've got another quarter that's not tapered. So I just kind of drew on me a line down the center. I'm going to go to the belt sander, and I'm just going to sand it back to that line. Okay, let's start comparing that with a gear. See what that looks like. And I think we better stop right there when we compare it to the way it fits into a gear. Goes in there just like that. They call for a 3/64 radius on the end. I think we'll just see if we can't lightly do it, and then we'll finish it out by hand. Okay, kind of like that. I think that looks pretty good. Okay, let's go back over the bench. Okay, we've made a light trip to the buffer. That fits in there like that. That fits in there like that. And I turned this diameter to match my bore. So I'm pretty happy with that fit. And this will fit right on there just like that. Pretty much in line like that. So there's our index pin. So we got pin, we got spring. We'll have to figure out what we're using for a knob here. And I will have some sort of a reproduction. I will probably CNC out a little stainless steel knob. I think I started programming those in previously, but I haven't done any yet. So that's probably what I'll do. That knob is used on several places on, I believe, all of the Atlas machines, one place or another. The mill uses several of them. The Shaper's got at least one on a guard, I believe, and the lathe has, 2 or 3 of them. So these, the little knobs that are on the end, and this other headstock came with a knob on it, but it was pretty well deteriorated. So anyway, that's the way they all go together. So we've got to do a knob on the back side of it to hold it, and this shaft gets drilled for the knob when the knob gets installed. And then I've got to turn my little lock for the top. I don't know if I'm going to do a standard one like this, or if I'm going to do something a little bit fancier than that. But anyway, there's one more part for the Atlas index centers. So hopefully you found this a little bit enjoyable. If you haven't hit that subscribe button and find this interesting, I would appreciate it. And if you hit the bell notification, you'll know when I put out a new video. Comments, suggestions, leave them in the comment section for me below. And as always, guys, thanks for taking the time to watch.